In this lab, we're going to take a look at some changes that take place in some common household materials. And this is the Physical and Chemical Properties lab. And so what we have is a set of baking soda, cornstarch, and salt. So like I said, things that you could often find in the cabinet at your house. And we'll kind of just zoom in here a little bit, or bring them a little bit closer, just to take and, so you can do some initial observations. What you have to do is you're going to be recording observations for each of the reactions that take place. And so if you just take a second at what the baking soda looks like, and I'm going to be putting these in each of the little container parts here in a minute. And then we have the cornstarch. Again, very similar in appearance, definitely have the same color. If you were to feel them, they'd feel a little bit different, but when you take a quick glance, they look very similar. And then, of course, the salt. There's a little bit difference in the structure of the salt, but basically we have, again, another white material. But there are some other things that you should be able to notice that's a little bit different between the three of those. And what we're going to do, we're going to compare them and see what happens when we actually react them with water, with vinegar, and with iodine. And so what I'm going to do, I'm actually going to put some into each of these. I'm going to move these out of the way just so we have some samples. And we want to be able to compare, and so I'm going to put a little bit of each into each one of these little openings or sections of my lab setup. And so we have 4 of the same. We're going to have one for comparison, just so it stays the same, and we can go back and refer to that. And so there's our baking soda, and what we're going to do, we're going to go through each one individually, and we're going to add, again, each of the materials one at a time, but again, like I said, we'll keep the one originally there. And so the first thing we're going to do, and again, just kind of off the screen here, we just have regular tap water. I have a thing of vinegar and another container of iodine. And so we're going to leave this first column as just going to be the standard one by themselves. And I believe on your lab it's just listed as the unmixed. So I'm not going to add anything in this column, but we're going to add the other stuff in the other column. So first thing we're going to do is just add some water and see if there's any reaction that takes place. And what we'll do, we'll stir it up a little bit just to see if there is any change or if anything happens. And so even after stirring, not too much to, write home about, and not too exciting, I guess. We go into the vinegar. You should be able to notice and almost hear a reaction, depending on how well my audio picks up. But we definitely have a reaction there. So you should be able to make some good observations about what is going on in that regard to the baking soda and vinegar. And then in the iodine, one of the things I want to point out with the iodine already has like a reddish, yellowish, and what they call it, an amber color. So when we put it on here, notice we still see that red, yellowish, that amber color, and it's just kind of absorbing in to the material. We'll put a little more in there just to kind of cover it up. So there you have your first 3. Again, we had our unmixed baking soda, we had our baking soda with water, our baking soda with vinegar, and then our baking soda with the iodine. The next one we're going to do is the cornstarch. So I'll put a little cornstarch. There's our sample comparison, the unmixed. We'll have one with the water, some with the vinegar, and then some with the iodine. I'm just going to wipe off my spoon there for a second. And first one, again, we're going to add some water. So I'll get a couple squirts in here. And if we mix it up, definitely liquefied, a lot of it dissolved, but it's a little bit different in appearance, and it could be because I have a different amount, but there's definitely some noticeable differences in what the baking soda and water look like versus the starch and water and how that looked. Next, we're going to go with the vinegar. I'm going to add a bunch of vinegar in here. Now, if you notice, there may be some slight reaction, and a lot of it's just when the vinegar is actually hitting and causing it to drop. Maybe there's a little bubbling, but nothing in comparison to what we saw up top. And so there's really not much going on with the vinegar and the cornstarch. Not to say that nothing, you know, that it didn't have anything, but nothing as dramatic as what we saw up here. Really, it just looks like it's just wet. Our iodine now, notice major difference with the cornstarch in the color. And again, when the liquid is hitting, it's kind of causing it to kind of splatter around, which is kind of what we saw here, causing just the cornstarch to kind of move all over the place. This is a recognizable difference in what we see from that first amber color. We're seeing this dark color. So one of the things that you also learn about in biology class, and you've often done in other science classes, maybe even in middle school, is the iodine starch test. So a good test for starch is iodine. You get this black or purple black color, and that's a positive test result. So that definitely shows that. I mean, the name itself has the word starch in it, but cornstarch has a lot of starch present. So notice our major one here that is different is this one. So this one we saw a major change, this one we saw a major change. So the next thing is, what's going to go on with the salt? We've had something happen with, the vinegar. We've had something happen with the iodine, not too much with the water so far. And if you've ever had any experience with salt, which most people do, if you ever have a sore throat, you might do a saltwater gargle. So I've put actually a lot of salt in here. This might not show up as good. So I'm actually going to put a lot more water in this one. Just to see if we can get it happen. Because again, if you've learned anything, depending on if you're in a chemistry class or food science class, you may have learned about solubility, and water can dissolve a lot. And we learned about the terms solute and solvent. And water is considered the universal solvent. It can dissolve a lot of things. Notice it really didn't make the other two disappear. And again, this is because I don't probably have enough water in here. I'm going to add a little more water. We'll do just a little comparison, see if we can get it to all go away. And you also learn that if the temperature goes up, if I increase the temperature of the water, then I can dissolve more salt in there. And so as I continue, notice it's starting to get a lot clearer because I added more water in. That helped. And so the solubility was better because I had more water, obviously. And so when we look at this, this is basically all gone. And, makes it look like the salt has disappeared. And now I have a clear material here where, again, even if I were to add a little more water, and I kind of ran out of water here, but if I add a little more water into this one, or a little more water into this one, I still don't have the ability to, totally go clear and dissolve all the material. And so it's a big recognizable difference. This one is definitely going to stay, it almost looks like milk. This one, notice the stuff just settled to the bottom, and I can stir it up and stir it up and stir it up, but it just doesn't really dissolve. Some of it dissolves, not to say that there isn't any that can dissolve, or that that it totally doesn't dissolve, but nothing like what happened with the salt. Okay, so it basically looks like our salt is gone. Now, of course, if I had left this here and leave it here for, a week or two, this would all evaporate and I'd be just, I'd have a layer of crystallized salt all around here. So noticeable difference there that it looks like the salt is gone, where the other two, it looks like everything is still there. If we go and we add the vinegar, see the reaction with vinegar and salt. Not really much of anything. All it does is make my salt look wet. And so again, big difference between the major reaction we saw up here with the bubbles, nothing really going on here, nothing really going on here. And then again with the iodine, we saw, basically the same color of iodine. We saw a major change with the cornstarch. And then finally put some iodine on our salt. And if you notice, just like the top with the baking soda, salt just stays this this orange, reddish, amber color. So again, no real change here. So as far as the summary and going over, especially when you get down to your second table, you should have been recording observations of what you see. You could be talking about colors, you could be talking about, bubbling or fizzing, things that you notice. Maybe it disappeared. We saw that in one of the scenarios. So those are the types of things you should be recording with your observations, things that you use your senses for to see. And on the second table, you're going to be recording and talking about the type of change that actually happened, whether it was a physical change or a chemical change. Now remember, a physical change is something that relates to, changing structure or phase, and I can actually get it back. So in one of these, I said I could probably get it back if I changed something. But a chemical change is when you end up with new materials or gases are given off, and I'm not able to get the same material back. And so when you have drastic changes, sometimes that could be a color change, but sometimes it's not a color change. For example, we made these orange, but that didn't change because the color was originally orange from the liquid iodine. But this one, definite difference. Okay, so there you have it. Make sure you go through and you can watch this again if you need to and use it to complete your lab. The setup here is the same as it should be on your lab and your data table. So make sure you fill in that data table completely and answer all questions accordingly.